Look up at the night sky. It seems crowded, doesn't it? Billions of stars, massive clouds of glowing gas, spiral galaxies drifting in the deep. We look at this and we think, this is the universe. But we are wrong. Everything you can see, every star, every planet, every atom in your body is just a lie. Or at least it is a very small part of the truth. Imagine looking at the ocean. You see the white foam frothing on top of the wave. If you thought the ocean was only the foam, you would miss the miles of deep black water underneath. The universe is exactly like that. The stars are just the foam. The rest is a dark, invisible ocean that we are only just beginning to notice. The first crack in our reality appeared in the 1930s. A Swiss astronomer named Fritz Zwicky was studying the Coma cluster, a massive group of galaxies millions of light years away. He measured how fast the galaxies were moving. According to the laws of physics, gravity holds a cluster together. The more mass it has, the faster the galaxies can orbit without flying away. But when Zwicky did the math, he found something impossible. The galaxies were moving too fast, way too fast. They were moving so quickly that the gravity of the visible stars shouldn't have been enough to hold them. The cluster should have ripped itself apart billions of years ago. Zwicky realized there had to be something else there. Invisible mass. He called it dunkel materia, dark matter. For decades, Zwicky was ignored. But in the 1970s, the evidence became undeniable. Astronomer Vera Rubin looked closer at individual spiral galaxies. Think of a solar system. The planets near the sun move fast. The planets far away move slow. That is how gravity works. The further out you go, the weaker it gets. Rubin expected galaxies to work the same way. The outer stars should be drifting slowly, but they weren't. The stars at the edge of the galaxy were spinning just as fast as the stars in the center. By all rights, these galaxies should have flung their outer stars into deep space like a carousel spinning out of control. But they stayed attached. This proved that the visible galaxy is sitting inside a massive, invisible halo of gravity that we cannot see. We finally had to name the ghost. We call it dark matter, but the name is misleading. It isn't dark like a shadow. A shadow blocks light. Dark matter is transparent. It does not reflect light. It does not absorb light. It does not emit light. You cannot touch it. If you held a lump of it in your hand, it would pass right through your flesh without interacting with your atoms. It interacts with the universe in only one way, gravity. It is the invisible glue. Without dark matter, there isn't enough gravity in the cosmos to build galaxies. Without it, the Milky Way would dissolve, the stars would disperse, and we would not exist. For a long time, skeptics argued that maybe our math was just wrong. Maybe gravity works differently at large scales. But in 2006, we found the smoking gun, the bullet cluster. We watched two massive galaxy clusters smash into each other. The visible matter, the hot gas, crashed in the middle and stopped creating a massive shock wave. But the gravity kept going. We saw the mass of the clusters pass right through the collision, leaving the visible matter behind. It was like watching two ghosts walk through a wall while their clothes got stuck on the surface. The ghosts are real. The dark matter is real. And it outweighs us 5-1. If dark matter is invisible, how do we know where it is? Because we can map its gravity. When we look at the universe on the largest possible scale, we see a pattern. It looks like a sponge or a spider web. This is the cosmic web. The strands of this web are made of dark matter. It creates a massive invisible 3D scaffold that spans the entire cosmos. Normal matter, the gas and stars, simply flows toward the gravity of these strands. Galaxies only form at the intersections of the web. Dark matter is the skeleton. The stars we see are just the thin layer of skin stretched over the bones. So what is this stuff? For a long time, we tried to find a boring answer. We hoped it was just dim matter. Maybe it was millions of black holes or brown dwarfs or cold dead planets that we just couldn't see. We called these machos massive compact halo objects, but we ruled them out. If there were that many black holes or planets, we would see them bending starlight everywhere we looked. We don't. It isn't rocks, it isn't gas, it isn't antimatter. It is something completely new. This forced physics into a corner. We had to invent a new particle. The leading theory is the WIMP, weakly interacting massive particles. Massive because they have gravity. Weakly interacting because they ignore everything else. Right now, as you sit there are likely millions of WIMPs passing through your body every second. They don't hit your atoms. They don't trigger your nerves. They pass through you, through the chair, and through the entire Earth as if it were empty space. To them, we are the ghosts. How do you catch a ghost? You wait for it to make a mistake. Scientists have built massive detectors deep underground in old gold mines or beneath mountains to shield them from cosmic radiation. Inside these detectors are tanks of supercooled liquid xenon. We are waiting for a single WIMP to accidentally bump into a xenon atom. If it does, it will produce a tiny microscopic flash of light. We have been listening in the dark for decades. So far, silence. The ghost has not knocked. While we were hunting for the glue, holding the universe together, we missed the force that was tearing it apart. It started with a mistake by the master himself. In the early 20th century, Albert Einstein published general relativity. His math showed that the universe should be unstable. Gravity should be pulling everything together into a crunch. But Einstein believed the universe was static, eternal, and unchanging. So he fudged the math. He added a number called the Cosmological Constant, a made-up force to push back against gravity and keep the universe still. He later called this his biggest blunder. But as it turns out, he was accidentally right. Einstein was wrong. The universe is not static. In the 1920s, Edwin Hubble discovered the truth. He realized that the galaxies are moving away from us. The universe is expanding. Think of a balloon with dots drawn on the surface. As you inflate the balloon, the dots don't move across the rubber. The rubber itself stretches. The space between the dots grows. For decades, we assumed this expansion was slowing down. After the Big Bang, gravity should be pulling everything back together. Like a ball thrown into the air, the universe should eventually slow, stop, and fall back down. That was the logical assumption. But in 1998, two teams of astronomers decided to measure how much it was slowing down. They used distant Type 1a supernovae as cosmic mile markers. When they looked at the data, they thought their telescopes were broken. The supernovae were dimmer than they should have been. They were further away than the math predicted. The expansion wasn't slowing down. It was speeding up. The ball wasn't falling back to Earth. It was rocketing into space faster and faster. Someone or something had stepped on the gas pedal. We had to give this new force a name. We called it dark energy. If dark matter is the glue that holds things together, dark energy is the wind that blows them apart. It is a property of empty space itself. Unlike matter, which dilutes as it spreads out, dark energy remains constant. This means that as the universe grows, it creates more space. More space contains more dark energy, which pushes harder, which creates more space. It is a runaway feedback loop. The more nothing there is, the stronger the nothing becomes. The history of the universe is a battle between these two titans. For the first few billion years, dark matter was winning. Gravity was strong enough to pull gas together to form the first stars and galaxies. It built the structure of the cosmos. But about 5 billion years ago, the balance shifted. The galaxies got too far apart. Gravity weakened. Dark energy took over. Now it is winning the tug of war. It is pushing the galaxies apart faster than gravity can hold them. The web is stretching to the breaking point. This leads to the most humbling statistic in all of science. When we tally up the energy budget of the universe, the results are terrifying. 68% is dark energy, 27% is dark matter, and everything else. The stars, the planets, the gas, the dust, your house, your body. Everyone you have ever loved 0.05%. We are the rounding error. We are not the universe. We are just the rare glowing impurities floating in a dark ocean of invisible forces we barely understand. To understand the fate of the universe, we have to understand the nature of nothingness. We used to think space was just a stage where events happened. But dark energy suggests that space is active. It has an intrinsic energy density. Here is the problem. As the universe expands, matter gets diluted. The galaxies get further apart. But dark energy does not dilute. If you double the size of the universe, you double the amount of dark energy. It is a force that feeds on its own success. The bigger the void gets, the harder it pushes. And the harder it pushes, the bigger the void gets. If this acceleration continues unchecked, it leads to the ultimate cosmic horror story. The Big Rip. Billions of years from now, dark energy could become strong enough to overcome gravity entirely. First, it will rip the galaxy clusters apart. The night sky will go black as our neighbors vanish. Then it will become stronger than the gravity of the Milky Way. Our galaxy will be shredded into lonely stars. But it won't stop there. It will eventually overpower the gravity of the sun. The Earth will be flung into the dark. Finally, in the last fraction of a second, it will overpower the forces holding your atoms together. Electrons will be ripped from protons. The universe will end in a violent shredding singularity. But let's step back from the edge of doom. There is a stranger possibility right here and now. We know dark matter exists. We assume it is just clouds of simple particles. But what if it is complex? What if there is a dark periodic table or dark chemistry? It is physically possible that there is a shadow biosphere. There could be planets, stars, or even life forms made of dark matter passing right through this room. We cannot see them. They cannot see us. We pass through each other like ghosts in a crowded hallway. We might be sharing this planet with a universe we can never touch. Whether or not shadow life exists, the lesson is the same. The history of science is the history of humanity realizing we aren't special. First, Copernicus told us Earth wasn't the center. Then Hubble told us the sun wasn't the center. Now the dark universe tells us that matter itself isn't the center. We are not the main characters of this story. We are just a rare exotic pollution. A dusting of glowing ash floating on a sea of invisible energy. By weight, we don't matter. But there is one thing that saves us from total insignificance. Dark matter has gravity. Dark energy has power. But as far as we know, neither of them has a mind. We may be small. We may be the minority. But we are the only part of the universe that can think. We are the only part that can look up and ask why. We are the foam on the ocean, but we are the only part of the ocean that knows it exists, and that makes the 5% worth fighting for.